Ever wondered how to manage hundreds of items in Python without losing your mind? Today, you will master lists and arrays to store, organize, and process data like a seasoned professional. Welcome to this hands-on lesson on Python lists and arrays. Data is at the core of every application we build, and being able to group related information together efficiently is a fundamental skill. Python gives us built-in lists for everyday flexibility, and specialized array structures when we need performance and numeric precision. Throughout this video, we will explore how they work under the hood, how to access and modify elements, and when you should choose one over the other in your own projects. A Python list is a versatile, ordered collection of items that can hold any mix of data types. You can store integers, strings, booleans, and even other lists all inside a single container. Lists are dynamic, meaning they can grow or shrink in size as your program runs, making them the go-to tool for general-purpose data collection in Python. Let us start by creating a simple list of task strings and performing basic modifications. We can append new items to the end, insert items at a specific index, and remove items when they are no longer needed. Notice how easy it is to update elements in place. Python lists use zero-based indexing, meaning the very first element sits at index 0. We can also use negative indices to count backward from the end of the list. Slicing lets us grab a subportion of a list using start, stop, and step parameters, which is incredibly handy when dealing with large sequences. Here we demonstrate how to access specific elements using positive and negative indices, and how to extract slices. Slicing creates a brand new list containing only the specified range of elements, leaving the original list untouched. Lists come packed with built-in methods that make data manipulation straightforward. You can sort items alphabetically or numerically, reverse the order in place, count occurrences, or find the index of a specific value. These operations help keep your code clean and concise. Let us take a jumbled list of numbers and apply some built-in methods. We will sort the numbers in ascending order and then reverse them. Notice that sort and reverse modify the list directly rather than returning a new one. While Python lists are flexible, they can store objects of any type, which requires extra memory overhead. For heavy numeric computation, the array module or external libraries like NumPy provide true arrays. Arrays enforce that every single element must be of the exact same data type, resulting in faster execution and tighter memory usage. Python includes a standard library module called array. We can create an array of signed integers by passing a type code I followed by our initial values. This gives us array-like behavior without needing any third-party installations. Choosing between a list and an array comes down to your project requirements. If you are building a general application with mixed data, lists are your best friend. If you are doing number crunching, simulations, or working with massive numeric datasets, arrays or NumPy vectors will save you memory and compute time. Let us perform an operation on our integer array. We can append new scores, iterate through them efficiently, and even convert the array back into a standard Python list when needed for compatibility with other libraries. You now know how to leverage Python lists for flexible, everyday data storage, and how to use the array module for strict, performance-oriented numeric tasks. Practice these concepts in your own scripts, and you will find data management become second nature. Thank you for watching, and happy coding!